Personal finance practice problem using OneNote. Present value and future value calculations with the help and use of tables problem number 2. Prepare to get financially fit with personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab down in the 1118 Present Value and Future Value Tables Prop 2 tab. Also note, when using OneNote, take a look at the Immersive Reader. Our presentations will also be in the text area. Same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're going to do the present value, future value with the help and use of tables. But before we do, we want to just recap what we have done thus far in prior presentations. Not that you need to do all these calculations or see the prior presentations to see the use of the tables, but because we want to see how multiple presentations or multiple calculations can be done for the same end result, so we know how they can be put together. We know the tool to best be used in our circumstance and can be following along with other people doing the same thing but in different ways. So we have the information saying the yearly earnings percent of an investment we're going to assume to be increasing at the 12%. In other words, we're assuming we have an investment, which could be stocks, it could be a home, it could be bonds, that we assume that is going to be increasing at an annual rate every year at 12%. We then are saying that how long will it take for the investment to double? In prior presentations, we did that or estimated the answer with the rule of 72, noting that you can estimate that answer without even having a starting point number, an original investment, to be doubling. Then we assume that we do have an investment number of 2,000. That usually makes it more concrete and allows us to calculate the similar thing in different ways. Note also that if you're asked this question by a book problem and they don't give you an investment amount, then you could pick one, usually like 100 or 1,000, so that you can use different methods and make it a little bit more concrete in your mind as you run the calculations. We here choosing 2,000 because we used 1,000 in a prior example, and we just want to note that you can use different investment starting points to be able to double it. That means we're asking then, with this investment, how long would it take for it to double, going from 2,000 to 4,000? Now, we got the time period using the rule of 72, which was just simply 72 divided by the rate of 12, approximating 6 years. We then did a calculation using a running balance table, which is good no matter what type of calculation we use, including the tables that we'll use now, because it will break out the actual interest per year, getting the ending balance here to be going over the 4,000, doubling our 2,000 starting point sometime between 6 and 7 years, just over 6 years, which is similar to the estimate we got with the rule of 72. We then did the calculation with the use of the functions in Excel, including the future value function, the present value function, and the number of periods function. This comes to a similar result as we would get if using the tables, similar kind of process. The Excel being the easiest kind of way to go, as well as the financial calculator. And then traditionally, then you would have the mathematical formulas being the long way to go, and the midpoint between them, meaning if you don't have a financial calculator or Excel for the easy way, but you don't want to do the mathematical formulas, then you have the tables, which were quite useful before we had financial calculators and Excel in front of us all the time when working. But now in practice, we would probably be using Excel in practice, and we'd still use the tables oftentimes, however, for book problems. So if you're doing this in a classroom, you will quite likely see tables, and they will quite likely try to take away your calculator, try to take away your Excel, and make you do stuff like you're scratching glyphs on a cave wall or something. Anyway, so you're still going to see tables in that instance. So then we did it with the actual functions, the formulas, the present value formula, the future value formula, and we did our calculations here, getting to our result as well, doing those methods. And now we can estimate the results with the tables, which is the last way we can do it, which again you might see on test questions. So notice a test will oftentimes, or a school will oftentimes basically try to first give you the actual form calculation here. They'll mention then the other formats of calculations like Excel Financial Calculator. And then when they test you, they're probably going to try to either test you on the formulas and or using the tables so that you can do multiple present and future value calculations quickly with the use of tables without having the calculator. So note, when we're using the tables, then realize that there's 4 tables that you need to keep in consideration. They will typically give you all 4. You'll have to choose the appropriate one for the task that you are working on. So there's going to be 2 present value tables, 2 future value tables, and each of those groups will have an annuity table and a one table, or in other words, a non-annuity table. And annuity means a series of payments. So here we're using non-annuity tables. So in other words, the 4 tables, present value of 1, we call it, that would be the non-annuity table. And then the present value annuity table, representing a series of payments, future value of 1, or the non-annuity table, and then the future value of the annuity table. Here, we can do this problem using the present value of 1 or future value of 1 tables. Now note, just like we looked at before, we're not kind of going directly into the end result, meaning we're not solving for the future value, we're not solving for the present value as we saw with the problems last time in a mathematical format. What we're solving for is n over here, which if you see it algebraically, you could see how you could do that. You could set up your algebraic equation, have all the known components, and then solve for n without reworking the equation to actually solve for n. You do it algebraically to figure that component. When you use the tables, for example, with the present value tables, you would typically take an amount that would be the future value, and then you'd multiply it times some component represented by the table to get to the present value. So you might then be saying, well, how then can I use the tables to back into the unknown of n if basically the table's designed to get us to the present value or future value end result? And this is a common kind of problem you might get in a test question. So we'll show you how to do that, but just note we're kind of backing into it or using the table a little bit differently to get there, which is quite common in a test situation. Now, when you look at the table, this is a present value table. We've got the number of periods on the left-hand side. We got the rate up top. Now, normally when they give you a table, they're going to have to simplify the numbers that they're going to be involved. So oftentimes they're going to make it annual type of tables, and the rates will be annual rates. But that will not always be the case, and it's not necessarily the case because the numbers over here do not have to represent years. They have to represent periods. So if you're compounding monthly or if you're compounding semi-annually, as you might see with bonds, these periods could represent a 6-month period or a 1-month period or so on. The problem with that is that the interest rate also has to match the interest rate per period. When you hear someone say an interest rate, if they do not specify a period, they typically mean per year, which is nice as a convention because the year represents basically, whole numbers, usually between 1 and 100 for the interest generally. If you break that down to a monthly rate, then the rates start to get quite small. They're probably not going to be even oftentimes, which is much more difficult to work with tables. That's not a problem when using something like Excel, however. So if they do a more complex problem, breaking something down into monthly kind of components or semi-monthly, they're still going to have to simplify it so that your table here will be picking up a proper rate. In other words, the rate up top, if you have something that's a fraction, it's going to be difficult to use the tables. If it's something that's going to be less than 1 or something like that, again, of course, difficult to use the tables if you have partial year rates, like monthly rates or something like that. So keep in mind those kind of limitations as we go through as well. So what we're looking for, we know the rate's going to be the 12%, and we know that we want to double this thing. So if we're looking at the present value table, we're imagining we're starting at the ending point, the future value, which means the ending point would be the 2,000 times 2 if we're doubling it, or 4,000. We're at the ending point. We're trying to get back then to the starting point, to the present value, which would be 2,000. So if we had 4,000 and we're trying to get back to 2,000, what we would have to multiply by is 0.5. So we're looking for something on the table to get us to 0.5. That's how we'll back into the number of years over here. So if I'm at the 12% column, I'm looking for a decimal here that gets to 0.5. And you can see that happens sometimes between year 6, where it's 0.5066. It's about 6 years. And then year 7, where it's 0.44523. So it's somewhere between those two, which is, of course, what we expect it to be, because when we did the rule of 72, it was 6 estimated, and it's actually a little bit over. I believe we came to 6.12. So notice this table format with this particular problem is not perfect because the periods are not even, which is highlighting one of the limitations of a table. Oftentimes, if you're working in a book problem, they'll make it even so that you get the exact answer there, but they might give you an approximation and say it's around 6 years or something like that, and still make you use the table to kind of approximate it. We could do the same thing with a future value table. So if I use the future value table, now I'm thinking where I'm going to end up from the table is usually the end result being the future value. I'm solving for the future value. So normally I'd have to multiply the present value times something to get to the future value. The future value we know should be twice the starting point of 2,000. It should be 4,000. So if I'm starting at 2,000 to get to 4,000, what would I have to multiply by to get to 4,000? We'd have to multiply by 2. So I'm looking for something in the table that would be at 2. I'm looking at column 12 again, same thing, but now I'm looking for the number to be 2. So if I go down, that happens somewhere between year 6, of course, which is 1.9738. That's pretty close. And 6 is approximately, the answer was 6.12 or something like that. And then year 7, it's at 2.2107. So it would once again be approximately, if I go back over here, around 6 years that we can use the tables to get to that period in that format.